Alright guys, we are looking at target 6.7, Mastery Learning Objective. I can use the midpoint formula, distance formula, and slope formula to prove a quadrilateral is a parallelogram. Okay, so now we're going to kind of use all the different things we've used to show that it is a parallelogram. Okay? So what is a parallelogram? A parallelogram is a quadrilateral that means it has four sides. Okay. So a parallelogram is a quadrilateral, so a four-sided shape where both sets of opposite sides are parallel. Okay? So you've probably seen it right. So this is a perfect picture of a parallelogram, right? This and this side are parallel, and this side and this side. So if they're across from each other, they are parallel. Okay? So we're going to look at 4 ways to prove a parallelogram. So the first way is just to use that definition. If you can show both pairs of opposite sides are parallelograms, if you can show that both sides of opposite sides are parallel, then you can say it's a parallelogram. And since we're talking about things being parallel, parallel is talking about our slope. Okay, so that one would be using our slope formula. The second one we're going to use is show both pairs of opposite sides are congruent. Okay? If the sides are congruent, that means I know the length of this is the same as the length of this, and same with these sides, right? The length of this is the same as the length of this. So to show both pairs of opposite sides are congruent, we'll be using our distance formula, or like we looked at before, right? Pythagorean's theorem is the distance formula. Okay. Number 3, show both pairs of opposite angles are congruent. This is the one we're not going to do because we don't really have a way with what we know of coordinate geometry to find angles. Okay, so we're not going to worry about anything with those angles in this unit. So we're going to relabel this one as number 3. Show one pair of opposite sides are congruent and parallel. So this one I have to do distance and slope. Right, but I only have to do it with one side. Here, I have to do the slope for all 4 sides, right? Here, I have to do the distance for all 4 sides. Here, I have to do the distance for 2 and slope for the same 2. Okay? And the last one, which we'll label as number 4, show the diagonals bisect each other. Okay? And if they bisect, they cut in half. And so for this one, we use our midpoint formula. Okay? If the 2 sides have the same midpoint, the 2 diagonals have the same midpoint, right? Then those diagonals will bisect each other. Alright, so we have 4 different methods. Let's look at an example. Show that the quadrilateral ABCD is a parallelogram. We are going to use method number 1. Okay, method number 1 is that the opposite sides are parallel. So again, if the opposite sides are parallel, I'm going to find the slopes. So the first thing I'm going to find is the slope of AB. So from A to B, the slope. Okay, well, right? for our slope, it's rise over run. So if I'm going from A to B, I'm going up 2. Remember, direction matters for positive and negative. And I'm going right 1, 2, 3, 4, 5, right? Now I'm going to find the slope of the opposite side. So I'm going to find the slope from C to D or D to C, it doesn't matter. I'm going to do D to C because then it's the same order that we did from A to B. So again, I'm going to go up 2, good, and across 5, fabulous. Then I'm going to say, yes, these two are parallel. Okay, so that's one set. Our first set, right? For method 1, you look back up, I need to go both pairs, so both sets of sides. Okay, so I still need to look at my second set of sides and show that those are parallel too. Okay, I'll go from A to D. We'll rise over run, I'm going to go down and over. That's down 4, over 3, right? So that's negative 4/3. And then I have to do this one from B to C. Okay, I'm going to go down. I'm sorry, I can't count. Go back. This isn't 4. This is 3. So negative 3/3, which is negative 1. Sorry. And then this is down 3 over 3. Right. So the slope of B to C is that negative 3 over 3, which is negative 1. Okay, so yes, these are parallel. That's our second set. So then I'm going to write my final sentence, A, B, C, D is a parallelogram because both sets of opposite sides are parallel. Okay, done. Not bad. All right, moving on. Looking at number 2, we're going to prove EFGH is a parallelogram. And we're going to prove EFGH is a parallelogram by method 2. Whole sets of sides congruent. Right? Okay, so I'll start with one side. Again, congruent means I'm finding the distance. Okay? So I'm going to find the distance from E to F. The distance equals, well, it's very similar. So if you do, right, put your numbers in still. I'm going up 2 and over 1, 2, 3, 4, 5. Okay. So really the distance squared equals 2 squared plus 5 squared. Right? The distance squared equals 29. Doing all sorts of things the whole way. Take the square root. This is just like proving our triangles. I just need to show they're the same, so I don't really have to do a lot with the, I don't have to like simplify or find the decimal for these. Okay, so distance equals square root of 29. So that's the one side, so then I do the same for the other side. It's also 2 and 5, so I'm thinking that it's a pretty good shot that it's going to be the same, right? Again, it's okay to say that if you see this, just jump to the end, right? You already know that, yep, that is what that's going to work out to. Again, use that like symmetry to your advantage to do less work. So those are congruent. But that's just one set. Right? I need both sets. So now we'll do this side. That's supposed to be an H, sorry. Distance squared equals, all right, I'm going 1, 2, 3, 2. Okay, colors are so helpful for these proofs too, guys. So if you want colors, right, that'd be great because I'm overlapping a lot, but with the different colors, it helps see what you're doing a little bit. Okay, so we have 3 squared plus 2 squared. So our distance squared equals 9 plus 4. Right. So our distance equals the square root of 13. We'll do the same thing for G to F. Hey, look at that. Again, a lot of times you already know, but again, proofs it's not that you know, it's that the person reading knows, right? So we do have to prove it, so we still have to show this. But we can say, hey, look, our algebra is the same, that we also get that same distance. So yes, these are congruent. That's set 2. Okay. So now I'm going to say my final statement. EFGH is a parallelogram because both sets of sides are congruent. Okay. So yes, EFGH is a parallelogram. We did it. All right, moving on to example 3. Prove that quadrilateral ABCD is a parallelogram given these vertices, okay? So we have A is -2, -3. So I'm going to go -2, -3. There's A. B is at 0, 5. C is at 6, 5. And D is at 4, -3. All right, moving right along, we are going to use method 3. One set one set parallel and congruent. Okay, so we can use either set or either set of sides. I'm going to choose the easy sides. Why not? These ones just going straight across. Okay? So the first thing I have to do is show that they're parallel. So I have to find the slope. Okay? So BC. Well, from B to C, my rise is nothing, right? Ah. And my run is 1, 2, 3. My run is 6. Okay, so 0 divided by 6 is 0. So we can't have things with zeros in them. Okay, easy. AD, same thing. So AD is also a slope of 0, right? Because I don't rise, I just run. So this is one set parallel. Now I have to show that the same set, I can't switch my sets of sides, but I have to show that the same set is congruent. And again, I chose the easy sides. 6. Right? I already know the distance of BC. I just have to count. Nice. Okay. Same thing with this side. Again, the distance here, easy. Six. I counted it. 1, 2, 3, 4, 5, 6. Okay, so you could do AB and CD or DC, whichever way you want to say it. But it's gonna be harder, so there's not much, right? So make it easy on yourself. Choose the easier side if there's an easier side option. Okay? So that is one set congruent. Okay, so this is a really good method to use if you have those straight lines. If one of your sides is just straight lines, this is really easy to use. Right? Okay, so then writing our statement, A, B, C, D. Because yes, one set of sides is parallel and congruent. Okay. All right, last example. And surprise, in example 4, we're going to use method 4, right? So method 4 say the diagonals bisect. And that just means they have the same midpoint. So I'm going to graph this. A is at -3, -4. B is at -1, 2. C is at 7, 0. And D is at 5, -6. Just double checking something. All right, so now we want to see if the diagonals bisect each other. So what I'm going to do is I'm going to the diagonals are across. So if I start at B, I'm going to go across to D. That's one diagonal. And I'm going to find the midpoint of that. Okay? Remember, for the midpoint, we're just taking an average. Okay? So it's my x plus my x over 2, and my y plus my y over 2. So we have negative 1 plus 5 over 2. And my y's are 2 plus negative 6 over 2. So negative 1 plus 5 is 4. 2 plus negative 6 is negative 4. And 4 divided by 2 is 2. Negative 4 divided by 2 is negative 2. So I'm going to go to 2, negative 2. Here is my midpoint. This midpoint means this and this are the same. Now I'm going to find my midpoint of the other one. Looks like it's promising. Okay, so AC again, my x plus my x, so that's negative 3 plus 7. And my y plus my y, so negative 4 plus 0. Okay. Negative 3 plus 7 is 4 over 2. Negative 4 plus 0 is negative 4 over 2. Hey, looky there. 2 and negative 2. Yeah. So this is the same as this. Okay. So yes, those diagonals cut each other in half because their midpoint is the same. Okay. So A, B, C, D is a parallelogram because the diagonals bisect each other. Okay. All right, that was a little bit longer, but we got through all 4 methods, and I'll see you guys tomorrow.